Students, okay, students, the hello to you, the CCS Academy and students. This is your fourth video, and this video will consist the second heading of your physics first chapter of 12th class, and that heading is electrical forces, or in detail, Colombian electrical forces. That is your second heading, which is present in your page 3 notes. I will show you later. What is the briefing required before this heading to start? As you know from the previous classes, gravitational forces are in 11 classes, and Newton's explain it quantitatively. Quantitatively means, as you know from my class, that is mathematically. The formula behind which the two masses of universe, whether small two masses, whether two big masses, or whether small or big masses, will interact with each other, and that Newton's law of gravitation is F equal to capital G m1 m2 by r square. You know all the aspect of 11th class. I'm not going to show you. On the basis of that, when electrical forces qualitatively come in nature, watched in nature by various scientists, and scientists needs what is the mathematical formula which connect these charges, or the interaction between these charges, which in this heading is known as electrical forces, Colombian electrical forces. Colombian found that these two charges, if q1 and q2 are separated by a distance r, where are separated, what is the medium of separation? It may be vacuum, solid, liquid, or gases. This law is valid for all the spaces, all the what you can states of matter, all the three states and vacuum as well as. So if q1 q2 are separated by distance r, which I will show you in the page 3 of your notes, that later I will show you, but first you hear the lecture carefully. He found that F is directly, if F is the force between electrical forces between these two charges, then this F is directly proportional to Q1 into Q2. What is the meaning of that? How he reached this formula? I am telling you, he reached that formula. F is directly proportional to Q1 by Q2 on the basis of various experiments he conducted before reaching this formula. First equation is F is directly proportional to q1 q2, and the second law, which comes from Coulomb's, use can say, but I am saying not, it is coming from the originally from Coulomb's. He took that idea from the Newton's gravitation's law, where Newton's took the formula F is inversely proportional to r square. And what is r? The distance between two masses in that classes. Here the distance would be between 2 point charges. So we have two equations. One is F is directly proportional to q1 q2, and F is inversely proportional to 1 by r square. This is equation first, and this is equation 2. You can see later in the attached notes, that is page number 3 and heading number 2, Coulomb's law and electrical forces. Now come to later. On combining 1 and 2, what I will get? I will get F is directly proportional to q1 q2 upon r square. As you earlier know, when this proportionality sign will remove, a proportionality constant will come. What is the formula? Now we have reached finally. I will show you later in the copy. You can connect with the notes as well as further. F is equal to k q1 q2 by r square. What is k? K is the proportionality constant, and whose value is coming experimentally 9 into 10 to the power 9 Newton meter square Coulomb minus 2. Okay. One more thing. Here the business is over from Colombian electrical forces. If you think so, no, not over. Because these Colombian electrical forces are totally different from the, not totally different, a bit different from the Newton's law of gravitation, which was applied by Newton's between two masses. Okay, what is the main different thing I am telling you? What was the formula of the 11th class? F equal to capital G m1 m2 by r square. Now what is the formula today? I am telling you, F is equal to k q1 q2 by r square. The value of k here is 9 into 10 power 9, and the unit attached I told you earlier. And what was in the 11th class? 6.67 into 10 power minus 11 with assigned unit whatsoever was there. So what is the need to further explain this k? Okay, further, as you will you can see in the page number 4. Now we are shifting to the notes, page number 4 of your attached notes, which I will show you later. K is equal to 1 by 4 pi epsilon naught, which was not originally present in the 11th class. This 1 by 4 pi epsilon naught, which is the value of k, makes totally different from the gravitational forces between two masses, which explained by the Sir Isaac Newton. And the Coulombian formula is k is equal to 1 by 4 pi epsilon naught. What is epsilon naught? Epsilon naught, I'm going to share a memory of my great teacher, Mr. Raman Tripathi. He told me when I was in 12th class, 20 years back. So he told me that what is epsilon naught? When I asked, and various other genius students asked to him, what is epsilon naught? He told us that this epsilon naught is the electrical measurement of that medium. What is electrical measurement? He wants to say, at that time we clearly could not understand because the tough concept was epsilon naught. Epsilon naught is electrical permittivity of free space. Everybody will know. You will also know from my lecture and from page number 4 of my notes. That value is epsilon naught 8.85 into 10 to the power minus 12, and the unit is Newton minus meter minus 2 Coulomb square. This is electrical permittivity. This electrical permittivity tells about the electrical property of medium. This type of concept was never present in the first formula. First formula means, I want to say, in the first natural gravitational forces created by the Sir Isaac Newton, F equal to capital G m1 m2 by r square. Capital G was the universal constant, but this k depends on epsilon. Means this k is not the you can say universal. It depends from medium to medium. So you can say what you can say from the my lecture. You can say that the sir, you want to say that this electrical property of medium varies medium to medium? Yes, varies. I am telling you. And I want to thank my teacher, Mr. Raman Tripathi, who told us to me so I could know the concept of epsilon naught. And I am telling you, my teacher told me, and I thanks to him, he told me about the aspect of epsilon naught. So I am telling you, he was genius. I am nothing behind. I am nothing before him. Nothing. Truly speaking. So I'm telling you further. As I told you, in this formula of Coulomb's electrical forces, F is equal to K Q1 Q2 by R square, further K equal to 1 by 4 pi epsilon naught. The value of epsilon tells about the electrical property of medium, which varies medium to medium. Okay, and the value is 8.85 into 10 to the minus 12 Newton minus meter minus 2 Coulomb square. Okay, this finishes your heading number 2. What were the similarities? Similarity was the one thing. F was inversely proportional to the r square, was in the Newton's law of gravitation as well as in the Coulombian's electrical forces. Okay, dear students, you could understand this thing. Okay, what was the dissimilarity? Dissimilarity was the epsilon naught. It was not present in the universal law of gravitation because capital G was universal constant. It was not varying at that time and at this time also with medium. Same for all medium. Universal. That's why we called it universal law of gravitation. But in this case, it depends on epsilon. One more thing. Gravitational forces are always attractive in nature. Always. But this time, like charges, I told you earlier, attract each other. Sorry, like charges always repel each other. Sorry to say you. But unlike charges, attract each other. Means plus attracts minus and vice versa. So this lecture, I told you in this video 4, will consist of your heading number 2 of class 12, chapter 1. Okay, take care of that, as well as page number 3 and 4, heading number 2. Okay, further I am going to attach you this one. Look at this. Okay, if you could not see, I will attach to the photo. Okay, then I am finishing this video number